Today we will be starting with the next part of the thermodynamics. So in the first part of the thermodynamics we have studied about system and different types of system. So today we will try to understand more about thermodynamical system. Let us assume that in a thermodynamical system we have a gas. Okay? If you have a gas trapped inside a closed container, of course in thermodynamics we always tell that our system is closed. In a sense, there will be no external addition of. In most of the thermodynamical studies, we consider closed systems. So, in a closed system, you cannot add any more molecules to it, or you cannot take out any molecules from it. So, this is a closed system. And what are the parameters involved? Which can be utilized to study and gather thermodynamical data. Please remember this, we have only few parameters, that is pressure, volume and temperature. These three are very important parameters which manages the thermodynamics of the entire system. We will try to understand more about it. Other than this, we also have this N. As I have already told you, this N parameter, that is number of moles, will remain constant since we are considering only closed system. In thermodynamics, we talk only about closed system. So in closed system, you can either add the reactant species into it or any species. Maybe it can be a gas, it can be liquid, or it can be solid. You cannot add it or you cannot take it out of the system. So N will remain constant. So this is ruled out. So only parameters which can give important information about thermodynamical system is pressure, volume and temperature. Parameters can be classified into two types. Let me try to help you to understand that. See, these parameters, whatever we have taught, or whatever the parameters that we can measure the most for thermodynamical systems, can be classified into two types. So one is called the state function, while the other can be called as path function. What is a state function and what is a path function? A state function is a parameter which depends only on the initial state and the final state, whereas path function is a parameter which depends on the path taken by the system to achieve final state from initial state. We will try to explain more about this. Now we will talk about a state function. State function. Let us assume a system is present in state A. What is state A? State A is nothing but a state. See, always remember, a gas is, whenever you have a gas will have a state based on value of pressure, volume and temperature. So if there is any change in any of this parameter, the state of the gas changes. It's just like your marks, right? So if you score some marks in your say in your test, and if you score some more marks in your another test, so what will happen to your state? Your state has increased if your performance is better. If your performance is bad, your state decreases. Is it not? It's just like that. So let us assume that state A as pressure P1, volume V1 and temperature T1, and state B as pressure P2, volume V2, temperature T2. Now, how do you achieve one state to another state? So, the process of taking a system from one state to another state in thermodynamics is called process. So, what is the process? It is what we do to take a system from one point to another point. Are you getting my point? Now, if I have to change a system from state A to state B, then I will do something like heating or cooling or something. So let me assume I am doing heating. So if I heat the system, say system takes this path and then achieves point B. If I do something like mechanical work, let me assume that system will take this path to achieve the so-called state B. Now, What will be the change in the pressure? If you ask me what will be the change in the pressure, I will directly tell that change in the pressure or difference in pressure is nothing but difference between initial state and the difference between final state and the initial state. Similarly, difference in the volume will be given as V2 minus V1 and difference in the temperature will be given as T2 minus T1. So here these parameters, it depends only on the initial state of the system and final state of the system. It doesn't depend on what path I have taken. So such functions which depends only on the initial state and the final state of the system are said to be state functions. Any function which depends on state of the system, initial and final. Such parameters are state functions. Now what are path functions? If you take work, see, if you take work, you have to, work depends on the path, is it not? So work depends on the path. If you call this as W1 and if you call this as W2 and if you call this as W3, obviously if you can see it, you can make it, your W2 will be very much lesser when compared to your W3, and your W3 will be very much lesser when compared to W1. Why is this? Because work done, amount of work done depends on the path taken. I hope you people are trying to understand this concept. I will try to explain it again. Please try to understand. State function is a function which depends on the initial state and the final state of the system, whereas path function is a function which depends on path taken by the system to achieve the final state. I hope you understood this. Always remember, basic parameter of any system, of any thermodynamical system which contains gas in it is pressure, volume, temperature, and all these three parameters are state functions. And derived parameter like work or heat, they are path functions. So you please remember this and please note it down. Now we will talk about process. I just told you what is a process. In thermodynamics, process is something that you do to take system from one state to another state. So there are different types of process. I will try to name a few. First one is called isobaric process. It doesn't go in a order. There is no such order here. So I just randomly pick the process and I'll try to help you with it. Now we'll try to understand what is isobaric process. Isobaric process is a process wherein which your bar remains same. Iso in the sense same, as you know. Iso means same. What is bar? Bar is pressure. So any process in which pressure doesn't vary. Remember, I am not telling that pressure is zero. Pressure will be there. But when you change the system from one state to another state, there will be no change whatsoever in the pressure. So here I am not telling that P is equal to 0. No, this is wrong. P is not equal to 0. But delta P will be equal to 0. Now what is the difference between P is equal to 0 and delta P is equal to 0? When I say P is equal to 0, it means that there is no pressure at all. When you don't have pressure at all, then your gas can expand. I am not, by telling isobaric process, I doesn't mean this. I mean this. There is no change in the pressure. When you change the state of system from initial state to final state, the pressure change will be 0. Any process which involves pressure change to be 0 is called isobaric. Now we will talk about second type of process, isochoric process. What is isochoric process? Now here iso means same, choric in the sense volume. So here in this process, your change in volume will become 0. Delta V will become 0. Remember this. So any process wherein which there is no change in volume, such process are called as isochoric process. Now we'll talk about isothermal process. Isothermal process. So what is isothermal process? Iso, same, thermal means temperature. So any process wherein which change in the temperature will become zero is called isothermal process. So these are all few examples of processes which has to be done in order to convert a system from one state to another state. Thank you for watching. For more such exciting videos, please subscribe, press the bell icon to get the latest updates. Thank you.